Okay, here we go, guys. I'm waiting on your packet to get downloaded and also hopefully get through this pretty quick because I got 20% left. All right, so we've got 4 pages today. The topic, as you can see, is on intersecting lines, okay? So here's a definition of a function, right? One key thing to realize with a function is for every x value or every input, there's only one output, okay? That's what defines a function. So we're looking at linear functions here. And we'll look at a little bit of function notation to start, okay? So if we have the function f of x equals 2x minus 3, we want to evaluate when x is 2. Well, basically what happens is 2 goes in as being defined as what x is. So anywhere in the formula that you see an x, you replace it with 2. Okay, and notationally, we'll just write, instead of f of x, we'll write f of 2 is equal to 2 times 2 minus 3, which is 1. Okay? If x is negative 1, in this next one, we can say that, well, f of negative 1 is going to be 2 times negative 1 minus 3. That's negative 2 minus 3. That's negative 5, okay? So remember, that's what function notation is. You have a formula, you have a function. If you're letting x be a number, that number takes the place of x and it gets plugged in. So here we're plugging 2 in for x. When x is negative 1, we're plugging negative 1 in for x. Now we're trying to simplify. Okay, in a similar way, let's do one more together. If f of x is 1/3 x plus 4, f of negative 2, well, that's going to be f of negative 2, it's going to be 1/3 times negative 2 plus 4, okay? So that's going to be negative 2/3 plus, and then 4 is really 12/3, so this is going to result in 10/3, okay? And then f of 3, well, that's going to be the same formula, but now, sorry guys, can't find my eraser here. But now x is going to be is 3, so we have 1/3 times 3 plus 4. So this is 1 plus 4, this is 5, okay? So we've got function notation, plugging in numbers for x and getting numerical values. Okay, now this is where it gets sometimes a little bit confusing, okay? So now we have a function, but now we're saying f of x is equal to 2. We're not saying f of 2, right? So this means that the output is 2, right? The final result is 2, and we want to set the equation equal to that. Okay, so this is a different notation, right? Here we had f of 2, here we have f of x equals 2, okay? So in this case, I'm just going to set the whole thing, f of x, well, that's 3x minus 4, and that's equal to 2, right? F of x is that, 2 is this, and now we can solve for x, right? So what we'll do is we'll add 4 to both sides, okay? If we do that, we get 3x is equal to 6. So x is equal to 6 over 3. So x is 2. Okay? And then if we want, we can plug 2 back into the original equation and see if it gives us what we want. So if we take 3 times 2, that's 6, minus 4, does that equal 2? Yes. Similarly, well, what happens if the function is equal to negative 1? Well, now we can let the function 3x minus 4 be negative 1. Okay, I'm going to skip some steps. Basically, I'm going to add 4 to both sides. Okay, plus 4 here, plus 4 here. And if I do that, that'll give us 3x is equal to 5. Okay, so again, all I did is basically add 4 to both sides. Okay, and now to get x by itself, we divide by 3. So x is equal to 5 over 3. Okay, so that's just a little bit with function notation. Okay, perpendicular bisectors. Well, we talked about perpendicular lines before, But now we have the idea of a bisector. Okay, and a bisector basically means it's going to cut something in two congruent or two equal parts. Okay, so if we have a perpendicular bisector of a line segment AB, the perpendicular bisector of a line segment AB is perpendicular to AB, right? So it's going to meet it at a right angle, and it also passes through the midpoint of AB. Okay, so and what we want to do is find the midpoint of AB, right? Find the slope of AB, calculate the perpendicular slope, right? So remember, this means the perpendicular slope. I don't like using the black. Let me go to blue. So the perpendicular slope is equal to 1 over the original line slope, okay, times -1. Okay, and rather, if we don't want to put that times -1, another way we could do it is just put a negative in front of the whole thing to start. So I'm going to say this is equal to -1 over the original line slope. And let me see if I can lasso this to make it look a little bit better. Let me see. A little bit. Yeah, now can I get this equals, see what happens, guys? See what happens? Now it doesn't recognize my word. Is equal to -1 over the original line slope. And then we can write the equation of a line again. So guys, we know, right, to write the equation of any line, we need a point. And in this case, that's going to be the midpoint of the segment, right? Because that's the common point that they share. That's right here. So maybe I'll call this A. This is B. This is the midpoint. How do we denote it? Big M of segment AB. Okay, so we need a point and we need a slope. And this is -1 over the slope of the line. Or sorry, the slope of the segment. -1 over the slope of AB. Okay, so now we have some numbers. We're gonna let me get maybe like a green. Yeah, actually an orange. Orange is cool. Okay, so we have a 2, 3, and 4, -6. So this might not be totally accurate to scale, but I'm just gonna fill the numbers in. And so B is B is 4, -6. So it's lower. So this is 4, -6. Okay, so let's find the midpoint first, right? So the midpoint, and we did this, I think maybe in the first class. So to find the midpoint, remember, we just are gonna take the average of the x's and the average of the y's. So we're gonna take the average of 2 and 4, that's gonna be 3. And we're gonna take the average of 3 and -6, which is gonna be -1.5, I believe. So let's just write that out. So the average of the x is going to be 2 plus 4 over 2. And the average of the y's is 3 plus -6 over 2. So this is going to equal 6 over 2, comma, -3 over 2. Okay, and that's really 3, -3 over 2. Okay, so that is the coordinate of this point here. This is 3, -3 over 2. Okay, we want the equation of a line, so we have a slope, right? But what we need is a sorry, we have the midpoint, we need a slope, okay? So let's find lowercase the slope of AB, and then we can take the negative reciprocal. So the slope of AB is going to equal 3 minus negative 6, okay? So remember, guys, this is the change in y, so I'm doing y1 or y2, however you want to think about it, but 3 minus negative 6, I have to divide by the change in x's, so I have to divide by 2 minus 4. Remember, if I started at this point, I did 3 minus negative 6, I've got to start again at the x value. So this is 2 minus 4, and that's going to be 9 over negative 2, which is negative 9 over 2. Okay, so then I'm going to write the slope perpendicular to AB. Well, it's just the negative reciprocal of this, so we flip it, becomes 2 over 9, and we change the sign. Okay, so that's positive 2 over 9. And now we can write our equation. Okay, our equation is y minus negative 3 over 2, right? So if I did y minus a negative, right, minus a negative is plus, equals, I always do that, it makes me mad, equals slope 2 over 9 times x minus 3, okay? So remember, guys, this is that form y minus y1 equals m x minus x1, okay? So our slope, or our point is 3, negative 3 over 2. So we've got x minus 3. We've got y plus 3 over 2. And then our slope, it goes here. Okay, one page down. I am going to do one more page and then break up the video. Just so you guys can split up too, and I can start loading this to get posted tomorrow. Okay, now we're going to talk about linear systems, okay? And we're going to talk about how to solve them. Now, the first way to solve it, and this is really great for Desmos, is graphing, okay? This is one way to solve. So we graph both lines, and we find, I'm going to call it the shared point, okay? So the point of intersection. If they intersect at a point, that's going to be a solution to the system because it solves both equations, okay? And that's exactly what we're saying here. The solution of a system is an ordered pair that solves both equations. Okay, so now we're going to graph these by hand, right? And so this is the downside, right? We're relying on graphical ability. And that's hard by hand sometimes. Okay, so if you can graph it accurately, it's great, but sometimes it's a challenge. And so, you know, we're going to use Desmos a lot. All right, here we go. So I'm going to go blue and black this time. Okay, so the first line I'm going to graph is this bottom one, okay? And the way I'm going to graph that is I'm going to plot the point 5, 3, right, guys? Because here's y, that's the x coordinate, x minus 5, y minus 3, okay? And the slope of that graph is 3. So I'm going to go up 3 units, 1, 2, 3, over 1. And I'm going to go down 3 units, 1, 2, 3, left 1, 1, 2, 3. Okay, and I'm just going to keep doing that. One more, 1, 2, 3, 1, okay? And I'll have to go here too, 1, 2, 3, 1. All right, and you can see I've got a bunch of points that are on that line. Okay, you guys would laugh if you could see me. I'm shifting my whole body around so I can get this drawn somewhat well. Okay, so we're gonna draw a line going through those. I don't like that line at all. Let's try it again. A little bit better. And then it's got to keep going through these. Okay, so there's one line. The other one, okay, I'm going to kind of use some cheat codes, and we've got a 2, a 3, and a 6. So I'm just going to pick some points. I'm going to let x be 0. So if x is 0, well, 3y is 6. That means y has to be 2. So 0, 2 is a point on the line. Okay, and then I'll let y be 0. And if y is 0, 2x equals 6. So x has to be 3. Okay, so I'm basically seeing what happens when x is 0, what happens when y is 0. Now I have 2 points, and I can graph, right? And if we look at the pattern is down 2 over 3. So down 2 over 3. And really, all I have to do is look at that small part, because that's kind of where we can see where the graphs are crossing. Okay, so the intersection, the solution to this system is whatever that point is. Estimate the point of intersection. Okay, well, I'm going to estimate it. I'm going to say 1, 2, 3. It looks like 3.9, maybe negative 0.8. Okay, I'm going to say it's 3.9, negative 0.8. But see, we're estimating, right? We're not sure if that's right. Okay, check your answers using Desmos. You know what? I wonder if I can do this here. Let's see, guys. Let's see how long it takes me. I think you can see this still. Yeah. Is it gonna let me load up Desmos? Yeah, okay. So here's the cool thing, right? So I forget the equational lines. What do we have? 2x plus 3y is 6. Okay, so I'm going to type that in. 2x plus 3y equals 6. Okay, and then the other one was, what was it, guys? Y minus 3 equals 3, x minus 5. Okay. Y minus 3 equals 3 times, in parentheses, x minus 5. Okay, now so check this out. There's the point. That fast. 3.818. Answer. And then and then the y coordinate was, oh yeah, see, okay, negative 0.545. Negative 0.545. Okay, so graphing gives us a close estimate, but you know, it's not totally right. Desmos, super useful, right? And what I really like, guys, a couple things is, I don't think I can laser point on here, but you can see, you can just put the equations in and you don't have to have y equals. And then you can mark, you can even label, you can call the point, whatever you want. So it's pretty cool. Okay, so I'm gonna stop that video, let it get uploading, charge my computer a little bit, and then I'll do the next 2 pages where we've got some geometry terms, median and altitude and perpendicular bisector, and then a word problem. And I think we'll use tech for both of these. Okay, I will see you guys soon.